Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be talking about similar triangles. Similar triangles are very similar, no pun intended, to congruent triangles, but you'll see there's a key difference here. So first, let's prove whether or not two triangles are similar or not. I'm going to draw two triangles just like this. These are not drawn to scale based on the numbers. I'm just warning you now, making up random numbers here. On the first triangle, we have 4, 12, and 10. And on the other triangle, we have 6, 18, and 15. Now let's label these triangles. Let's call this triangle ABC, and let's call this triangle DEF. So how do I know if two triangles are similar or not? Basically, all you need to do is you need to say the sides of ABC are proportional to sides DEF. Now, what the heck does that mean? How do I prove if it's proportional or not? It's simple. All you do is you need to make sure the corresponding sides fit over top of each other in an equation, specifically this equation. So first, I'm going to write 4 over 6 because that is the side on AB. 4 corresponds to the side DE, which is 6. Put it over a fraction as each other, and then we're going to set it equal to the next side, which is 12 over 18. Again, I'm doing left on top, right on the bottom. And then another equal sign goes, and then I'm going to compare the two bottom ones, 10 over 15. And in order for these triangles to be similar, this equation needs to match. In other words, all of these sides need to be proportional to each other. Let's see what happens when I reduce. 4 over 6, that's going to be 0.66 repeating. Then we have 12 over 18, which is the exact same thing, 0.66 repeating. And then 10 over 15 is the exact same thing, 0.66 repeating. So in other words, yes, the triangles are similar to each other. And the way you'd write that is you would say triangle ABC is similar. That's the similar symbol. It's just a tilde symbol. And you would say it's similar to triangle DEF. And the order matters. You'll notice ABC matches DEF in that order. Now, one thing I do want to say, let's say you did the reverse of this. Let me just create some room here. Let's say instead of the top over the bottom, what if I wanted to do the bottom over the top? In other words, 6 over 4 equals 18 over 12 equals 15 over 10. If you plug this in your calculator, you'll see this will work as well, but the thing is you have to be consistent. In other words, you'll notice all the top numbers are from my right triangle and all the bottom numbers are from my left triangle. So as long as you're consistent, you're going to be fine with similar triangles. Now, that is one of two ways you can prove that triangles are similar. To prove that triangles are similar, you need one of two things. Number one, you need all sides need to be proportional. Remember, proportional means the fraction thing that we just did in the problem above. And you need all the sides to be proportional. In other words, 3 matching pairs, 6 total. And that doesn't happen all the time. So the second way you can prove that triangles are similar is if you have AA, not Alcoholics Anonymous, but angle, angle. You need 2 angles to be congruent. Not sides, 2 angles to be congruent. And why is that? Because let's just say hypothetically, let me just make something up, that you have a 30-degree angle here and a 50-degree angle here. And then I'll draw another triangle that's bigger. But still, angles don't care how big the sides are. Angles care how big the angles are. So as soon as you get 2 angles are congruent, you actually have all 3 angles are congruent. Why is that? Because remember, when you have 2 angles, you already know the third one. It's 180 minus 30 minus 50, which is 100 degrees. And that's going to be true for both triangles. So as soon as you prove that 2 angles are congruent, you automatically have the third, and that means they're at least similar. Keep in mind, similar is not the only option we could have had here. These could also be congruent, but the only way you're going to get congruent is if, for instance, these side lengths match as well. But don't expect to see that when your question asks for similar triangles. You shouldn't be expecting congruent. You should be expecting similar. So with that, let's look at a couple more examples. So for this next triangle, I'm going to have two triangles. This one has a length of 20 here and 36 here. And I'm going to give you some angles. This angle is 25 degrees. This angle is 40 degrees. Now for this second triangle over here, I want you to tell me, first of all, if they're similar or not. If this side is 5, this side is 16, this angle is 25, and this angle up top is 115 degrees. I would like to know if these two triangles are similar or not. So again, there's two ways you can prove it. Number one, are all the sides proportional? Since I don't have all 6 sides, I'm missing 2. I'm missing this side and this side. So you can't prove the sides are proportional. So we have to look at the angles. Are all 3 angles similar and congruent? So you'll notice we're missing an angle in each triangle. Let's find the missing triangle by doing, for the left one, 180 minus 25 minus 40. That's going to be 180 minus 65, which is 115 degrees. So that angle is 115. That matches with the right triangle, which means I bet this triangle is going to be 40 degrees as well, right there. And of course you can check that by doing 180 minus 25 minus 115, and you will get 40 degrees, which is the missing angle. So right there we have not just 2 angles, but all 3 angles are congruent, which means yes, this is a similar triangle. Now the last question I have for you is, how can I find these missing sides? The one down here and the one over here. It's simple. You just have to set up a set of proportions. So again, this looks like the following. If I do left over right, then I'm saying for one side 20, this guy right here, divided by 5, this side right here, must be equal to, let's do this side next. This is 36. This is missing. I'll give it a variable. I'll call it x, so 36 over x. And then for the last side, the left triangle is missing. I'll call it variable y. And then in the denominator, I have this triangle here, which is 16. So now what I need to do is I need to solve for x and y. It makes no sense to do this all in one step. You cannot solve this with all 3 at once. So you need to look at just 2 at a time. Here's what I'm saying. Let's do 20 over 5 equals 36 over x. Forget about the y for right now. Just do these 2. Now there's 2 ways you can solve this. The first way is you can cross multiply, and you'll get 20x equals 5 times 36. That's 180. And so then x is going to be 180 over 20, which is just 9. And by the way, the second way you could have done this is you could have said 20 divided by 5 is just 4 equals 36 over x. Multiply the x on both sides, 4x equals 36, and then divide by 4, x will be 9. I think that way's a little bit easier, but both ways get you the same answer, x equals 9. Now when we want to solve for y, again, there's 2 things you can do. One is 20 over 5 equals y over 16. That's one thing. The other thing you can do is the other side, 36 over x, and now we know x is 9 equals y over 16. And honestly, you'll get the same result, so it doesn't matter which one you do. 20 over 5 is just 4 equals y over 16. Multiply both sides by 16 to eliminate it, and you'll get 4 times 16 is 64. And there's y. Now, for the next 2 examples with similar triangles, these are going to be the hardest ones of all, and they're also the most important. So one thing about similar triangles is you know if a triangle's similar automatically. If you have a line right here cutting the triangle, not in half, but you're kind of splitting it into this shape right here, and let's just say both of these angles right here are right angles, and that's all you know. So first I want to tell you, you actually do know that 2 angles are congruent. Let me explain. Let me highlight this triangle in blue, and then I'll highlight the other triangle in red. Okay? I'm making the argument that you have 2 angles. One angle here for the right angle, and then since they share an angle right there in the corner, they must be equal. You do have angle. These triangles are similar to each other. Now let me erase this to give myself more room. So now let me give you the side lengths. Let's call this distance from here to here 4. Let's call this distance from here to here x. Let's call this height here y. and then I'm going to say the entire thing is 10. And let's say this side is 3. So this looks like a pretty challenging problem, because it is. But the good news is, once we know the steps, it's actually not that bad. So the first thing you're going to do is you need to figure out what sides are proportional to each other. In other words, let me just set up the proportions. For the bottom one, I would say the smaller triangle 4 divided by the bigger triangle, and this is the fun part, the bigger triangle has a side of 4 plus x. Why? Because if I want to count the entire base, it's not just x, it's 4 plus x to get the whole base. So that's one of my proportions. Another proportion is for this side to this side, the vertical, it's going to be 3 over y. Notice this is not y plus 3. Why not? Because the 3 is not even connected to the y, unlike the 4 and the x below. And then the last proportion, it's going to be this side, which I don't even have a name for it, so I'll just call it z. So that means z over 10 must also be another proportion. Now the bad news is no matter which one you choose, you're going to have an unknown variable. The secret to this problem is actually finding z first. How come? Because let me draw this smaller triangle by itself right here. Okay, here's just the smaller triangle with a base of 4, a height of 3, and a right angle, and you're going to solve for z by using the Pythagorean theorem. You can use Pythagorean theorem because you have a right angle and because you have two sides already. So that means z squared equals 4 squared plus 3 squared. Hopefully I don't have to explain Pythagorean theorem to you. And then z squared is going to equal 16 plus 9. That means z squared equals 25. And you take the square root and z equals 5. Now, the question wasn't asking for z, but now that I have z, I can fill it in right here. And now that's 5 over 10, or 1/2. And now I can solve for whatever I want. Let's solve for y first. So what I'm saying is 3 over y equals 5 over 10. Let's cross multiply. So on the left, 30, and on the right, 5y. Divide both sides by 5, y equals 6. And there's our answer for y. And now just one more for x. Remember the proportion was 4 over 4 plus x equals 5 over 10. Again, I'm going to cross multiply here. 4 times 10 is 40. On the right, we have 5 times the quantity, 4 plus x. So yes, I will have to distribute this 5 to both terms. So 40 equals 20 plus 5x. Then we just subtract 20 from both sides. And you will get 20 equals 5x. And then you divide by 5, and you'll get 4 equals x. Now, by the way, there's more than one way to do this algebra. The most important part, though, is that the proportions are the most important part. And then if you, instead of using 5 over 10, instead if you want to convert that to 1/2, that's fine as well. I don't care. But as long as you're setting up the proportions correctly, that's the important part. Now, let's look at just one more example, and then we'll be done for today. So let's say I have this big triangle right here, and I'm going to put a line in the middle. I'm going to tell you, well, I don't know if it's exactly the middle. It's just somewhere in the middle. Now, the one thing I'll tell you is that these lines are parallel. This is different than the last one. The last one, they were right angles. In this problem, it's just parallel. Now, one of the properties of parallel lines is the fact that this angle is going to be congruent to this angle, and this angle in red is going to be congruent to that angle. This is known as corresponding angles. I'll just write that down for you. Now, the good news is you don't have to actually write this on the test. It's assumed that you already know this. By the way, since both triangles, the bigger one and the smaller one, share the top angle, you've got all three angles are congruent. So immediately you know they're similar. Now, let's say this entire side is 15. I'm going to say this shorter side is x, and this side here is y. And I'm also going to tell you this side here, the middle line is 8, and the bottom line is 12. And now I would like to find x and y again. So here's what I'm going to do. First things first, set up the proportions. Top over bottom, 8 over 12 equals, for the smaller triangle, we have y, and for the entire thing, You can actually say one of two things. You can either say 15 because that's the whole thing, or you can say x plus y. It doesn't matter which one you say. I'll write 15 for right now because that way we can solve for y. So all I need to do is I need to cross multiply here. 8 times 15 is 120 equals 12y. Divide both sides by 12. You'll get y equals 10. And then if you want to find x, just remember, x plus y equals the total 15. X plus y equals 15. We just said that y is 10. So x plus 10 equals 15, which means that x equals 5. Not so bad. So hopefully you have a better understanding now of similar triangles. If you have any questions, please post them in the comments below. Of course, thank you all for watching, and I'll see you in the next video. Until then, take care, and bye-bye.